and I'll hold the presentation, and we can talk. So let me just get this thing going, and share screen, share sound, and I think that should be it. So I'm just going to play a little bit, and then we're going to check whether you can hear this. Welcome to BITUG 2021. Did you guys hear that?
Yep, can hear that. Thanks, Randall.
Perfect. Okay, I'm going to let it run now. And making your development and deployment more resilient and secure using NSGit, now officially part of the HPE Showcase program. I am Randall Becker, Chief Architect of the NSGit product. In this presentation, I will go into the problem statement. What are we trying to solve? An introduction to NSGit and Git and some basic concepts. A description of how you do CI/CD when dealing with Guardian and what the architecture for it is. And then going into a little bit about NSGit and Git typical operations. So let's start at the beginning. This is a very brief introduction to the enterprise class version control that applies across the board no matter where you are in your organization, but happens to also work under Guardian. And the glue, the key to all of this, is Git. So let's start with the important slide. Why are we here? What makes NSGit so important to our organization? Well, with NSGit, and of course backed by Git, you always know what you've got in production. That's the biggest question that needs to be answered at all times. Then we get to how can we reduce our time to market? And that also comes into some of the unique features that NSGit and Git bring into an organization. That's why organizations have deployed Git very broadly and why it is really the gold standard for version control systems in the world. A series of conflicting motivations that your boss or your boss's boss has when looking at why we do all this, why we put CI/CD in. So number one, we're looking at trying to get to market faster with each one of our features. But if we push too fast, we're going to end up with unaudited code getting into production, which is hackable and can cause some serious issues and serious money loss. But then we have the perception that, being compliant is actually going to slow things down. So the CIO needs to balance all of these things. Fortunately, with NSGit, all of this stuff can be handled at the same time. With all that out of the way, what is Git? Well, Git is a distributed version control system. It is the gold standard. It is used to manage virtually all major operating systems, most major applications, open source projects, and probably most of the applications in your organization. It is pervasive. But other than version control, Git has some key capabilities. The major ones include software transport, which allows code to be moved from anywhere to anywhere, as long as you've got the security to do that, with 100% fidelity, all of the audit information going with it, and tracks who did what, where, and when. And this is crucial when trying to understand how your application is evolving and being deployed. What is NSGit? Simply put, NSGit is a front end to Git. It is the translator that allows Git to understand all Guardian content going into Git and coming out of Git. On its own, Git just understands simple text files. It really has no knowledge of all of our complex and subtle attributes that we've got to maintain in the Guardian space. So we need NSGit to be able to take stuff and put it into Git and get it out again. And this includes all NScribe file types, native, non-native objects, SCOBALs, DDL dictionaries, production scripts, all of this stuff. And importantly, it's also got capability to handle incremental release builds, which is really kind of important for most of us. So let's take a look at a typical DevOps stack on NonStop. At the top, you've got your applications. At the bottom, you've got your operating system. In between, you've got your security, you've got your access and control, you've got your TMF, Java, and all that. And right below applications, you've got your development environment. And this is the thing that helps both work with the application and deploy it. Here are the key benefits to development and operations for NSGit of what NSGit brings to the table. It brings a Git interface. So the standard Git commands that you've got anywhere else where Git is used are available right from Tackle. NSGit works right on top of Git. Git sits in OSS and does all the Git stuff. NSGit manages the hierarchies, the subvolumes, the name mapping, so that you've got your Guardian names in Guardian. You can have OSS names in OSS. You can have multiple subvolumes in a repository instead of, one repository, one subvolume, which can get really, really cumbersome. You've got support for all of the Guardian types, native, non-native, POBJ, DDL dictionaries, SQLMP, and very importantly, every attribute that NScribe has is preserved in the NSGit metadata. Okay, so we're finally here. Now I'm going to talk about the actual CI/CD architecture and how to make all this work. So starting at a pretty high level here, we've got the overall view of how NSGit fits in. You've got your enterprise Git servers that really tie everything together. This is your backbone. This is the stuff that you've deployed throughout your organization or are maybe considering it. And you've got Git that is used to talk to the enterprise Git servers. This is the moving of the audit trails, the code, the history, all that to and from the enterprise Git servers. And you've got NSGit at the front, which users talk to, developers talk to it, operators talk to it, your automation talks to it, and you use NSGit to take code out of Git and pre-stage it into your pre-production environments. It's important to note here that you only need NSGit at the endpoints. No matter how complicated your Git architecture is behind the scenes, NSGit is there when you're interacting with Guardian and only when you're interacting with Guardian. We find that because NSGit manages the name mapping, the dual mode file names, where you've got your Guardian names in Guardian and your OSS names in OSS representing the same files, you can add file extensions into your application. This allows you to co-develop or develop part of your application in Eclipse, part of your application in Guardian, and actually both at the same time. So you can, if you want, use NSGit to do your application development and then move code down to Guardian to do your unit testing. Or not. I mean, this is just one of those optional things that is part of the architecture. Here's where we've got in our architecture the mechanisms of connecting. So noting here, Git communicates over SSH. It can also communicate over OpenSSL, but from a really secure standpoint, you want to use NonStop SSH to make this all work. Now, in our enterprise Git server cloud, which we've expanded in this particular slide, there are a whole bunch of different enterprise Git server implementations that are out there. You've got your Bitbucket, which is probably the most popular current version out there. You've then got GitLab. You've got GitHub Enterprise, which is, I'm not sure how widely adopted that is, but I do know some customers who have got it. And we've got a relatively new player, which is the Azure Git, which is sort of the evolution of the Visual Studio's TFS that has morphed into another variant of an enterprise Git server. Pulling this all together is what would be Jenkins, which is, call it NetBatch on steroids. You can think of it that way. And it monitors changes in branches within the entire Git ecosystem to trigger actions, events, deployments, automated testing, automated builds, release construction. Now, Jenkins doesn't have to be the only one you use. Any automated tooling, Travis as an example. There's lots of different ones out there. As long as these things communicate over SSH, you can do this. And you can do this with an OSS application. You can do this with a Guardian application. SSH is the glue that holds the entire architecture together. Now at the 5,000 foot level, let's say the development manager or the detailed architecture level of this, we're starting to see a lot of the individual pieces. And what we've got on the developer side is the developer clones, and these are copies of the application, whether they're per developer or per team, per environment. There are lots of different ways of arranging the clones being copies of the application. These clones allow you to do parallel development. This is a big part of the power of NSGit and Git, where you can do development on one thing at one time and in another thing at the same time. You can switch branches, switch what you're working on very, very rapidly, and work on what you need to work on when you need to work on it. So that's a really important part of how the overall Git architecture works. This is no different than how you work on Git with any other platform. So if you're building an Android, you're using the same development processes as you're using on NonStop. This is a pretty cool ability that you've got the same processes now, rather than something for NonStop and then something for the rest of the organization. When changes are done, the changes are pushed up through NSGit to your source repository in the enterprise server, and that's called code delivery. The code delivery is a crucial phase because that's when things start getting visible. That's when you start talking about a pull request. Now, the pull request is how you integrate changes from one developer to another into your common development base. Once you've satisfied that, you've merged everything together, Jenkins kicks off and says, hey, something happened. I've got to do a build. It might even be a release build. And that happens in a purely automated environment. It is still Guardian, but it's initiated from a Jenkins agent that is driving the build test process. And this is happening because of the satisfying of a pull request, the merge that happens in one of your enterprise servers. From there, the release that's built gets pushed up to the release repository with all of the history, all of the audit trail of where everything came from. And any of your intermediate libraries that got built, those also go into the release repository. And then from there, these can be deployed to your production staging areas. Do they go directly to production? Probably not when we're dealing with Guardian. In some environments, like Android, this is often used to just kick an application out to the Google Play Store. But, what we're looking at is staging. Now, we can do all of that without having a human being involved in getting the code all the way through to the production staging area. But we're probably not going to do that. So we introduce approvals into our pipeline to make sure that nothing happens without it being, unexpected. So we're now down at ground level. And let's have a look now at some of the basic NSGit operations, some of the interactions that a developer would normally use for doing their work on an ongoing basis. You're going to see that it's really not very complex. The interactions that developers have are very straightforward and very simple. So now we get into the 4 key commands that are used everywhere. I mean everywhere. This is all platforms. Everybody uses these commands. Now, I've not included the clone, which is the one time that a developer goes out and says, I'd like a copy of the application, please. That's really just done once, so it's not included in the 90% of interactions. The switch command is really the important one here. The switch command allows a developer to start working on a new thing. So a new feature, a new bug fix. It also allows a developer to change context. So, you're working on an enhancement that's taking 3 weeks, but suddenly you've got a fix. You got to do a bug fix. So the switch command is used to switch over to a bug fix branch, allowing you to do your bug fix, deliver it, and then you can switch back to what you were working on before. And NSGit keeps track of all this for you. You don't have to remember what files was I working on, because NSGit takes care of that. The add files command is really used to stage the files. So it's like pre-production. It's kind of pre-delivery. And you can think of the add command as a pre-delivery operation. The typical way of using it is just to say, add everything. Add everything that changed. So NSGit figures out what are the files that changed that the developer had been working on and stages those. The files that have not changed, they don't get touched because they're not modified. And so the amount of thinking that the developer has to do about what have I changed, what am I working on, I don't know, I forget, I'm going to have to keep a paper list, that doesn't exist in the NSGit world. You can just say, add what I changed. And that's it. You do that at the end of day or at the end of delivery, and you just go from there. The commit locks the files in, not locks is a bad word here in Git, but it takes the files that you've staged and creates a new full version within the Git system of all of the things that have changed. So all of the header files, the implementation files, any test scripts, test suite changes, all of that can go in one commit, one new version in the system, so that they all move together. It's an atomic operation. And you don't break that apart. You're not going to deliver a header file and then you're going to deliver a body. No, you deliver everything together in one shot. And the push is the delivery itself. So that's the command that takes the code, uses NonStop SSH, and pushes the code all the way up to the source repository. Let's just say it's Bitbucket for here. And that's your delivery. There are some information commands like log and so forth for querying what's going on. But in terms of what developers really have to do during the day, a switch, an add, a commit, and a push. Typically, that's 4 commands that you might have to do during the course of a day, once each. Like, it's not like you have to do these multiple times. You don't have to go find what file do I want to change, request it. You don't do that anymore. This is, that's not part of what Git does. But a really important aspect of reducing time and errors when getting code from development into production is reducing the human factor, reducing the touch points. How much interaction do you have with the code, with moving pieces around and having to have a human being involved in decision making or involved in moving the code? Every time you do, you slow things down. Look, computers are fast and cheap. Okay, they might be expensive-ish, but they're not as expensive as the human beings involved in the deployment process. So what we're trying to do is ultimately reduce the interactions. Let humans do what they're really good at, which is delivering capability. So what do we get out of this? We've implemented NSGit and Git and enterprise Git servers for development and production. This gives us, PCI compliance and Swift compliance and all kinds of other types of compliance now at very little cost to our effort. The audit capability of Git is built into it. Nothing that I've done in the discussion here has shown that we've had to do extra work for audit. It's all just normal development flow. What we're doing here is we're putting in safeguards throughout our supply chain and making sure that every step along the way is as verifiable as possible. We're using standard technologies now. Git is a standard. It is the gold standard for both managing code and moving code. And NSGit is the only Guardian solution that allows the integration of Guardian into the standard process. It speeds things up and it reduces risk. So, that's what you get with the Git ecosystem. You get a good, solid architecture for building reliable deployment of your features. I'd like to thank everyone for attending. I hope you found this useful and informative. Please remember that NSGit is now part of the HPE Showcase program. There are a lot of benefits to your organization that NSGit brings, and I am happy to discuss them with you at any point in time. For licensing information, please contact me directly or discuss NSGit with your HPE account team. Thank you again for attending.
Well, I'm back now. I hope you enjoyed that, and if there are any questions, the floor is open. No questions? None at all? Am I still here?
Yes, you are.
Okay. All right. I mean, we can hang out here. We can go back to the main room, I suppose.
Yeah, thanks for that, Randall. Yeah, I think everybody's going to get chucked back into the main room anyway, automatically, it looks like, because I've got a little thing on my screen that says all the breakout rooms are going to close in 30 seconds.
Okay.
But thank you.
I hope it was informative. And I'm always here to answer questions. So if you need to reach me, randall.becker@nexbridge.ca. That actually gets to my phone. Don't tell my wife that I said that, but you can reach me at any point.
Excellent. And of course, this presentation will go up on the BITUG YouTube channel, so people can listen.